Hi and welcome to John's Maths book. In this video, I'm going to be introducing the unit circle and how it applies to trigonometry. If you like the video, then please hit the like button and I'd be delighted and honoured if you'd subscribe to the channel. Without further ado, let's go over to the whiteboard. On the left, we have a unit circle with radius equal to 1. For each angle on the circle, we can construct a 90-degree triangle. Let's look at the 30-degree angle, theta, that we've created on the diagram. The hypotenuse of the triangle we created is the radius of the circle, which in this case is 1. The other two sides of the triangle, the adjacent and opposite sides, are values of less than 1. The length of these two sides is dependent on the angle theta created on the unit circle. Each point on the unit circle has an x and y coordinate. The x coordinate is equal to the cosine of theta, the angle that's created on the unit circle. The y coordinate is the sine of theta. Now let's go around our unit circle and take a look at some points. So let's start here at point A, and the x, y coordinates of point A are equal to 1 for x and 0 for y. The angle theta at this point is equal to 0. This means that the cosine of 0 is equal to 1 and the sine of 0 is equal to 0. We now move around the circle in an anticlockwise direction to point B. We see that in this case theta is equal to 90 degrees or pi by 2 radians. The coordinate x and y at this point is x is equal to 0 and y is equal to 1. So therefore the cosine of 90 degrees is equal to 0 and the sine of 90 degrees is equal to 1. Let's now extend this to point C on the circle, where theta is now equal to 180 degrees or pi radians. The coordinates at this point, x and y, are equal to -1 and 0. So the cosine of 180 degrees is equal to -1 and the sine of 180 degrees is equal to 0. Let's extend this even further and move to point D on the curve. In this case, theta is equal to 270 degrees or 3 pi by 2 radians. At this point, the xy coordinates are x is 0, y is -1. So the cosine of 270 is equal to 0 and the sine of 270 degrees is equal to -1. When we reach point A again, we've travelled 360 degrees around the circle and the cycle will then continue. As we've moved around our circle, we've noticed that the cosine of theta is always less than or equal to 1 and greater than or equal to -1. Similarly, with the sine of theta, we've noticed that it's always less than or equal to 1 and greater than or equal to -1. Now let's look at some different points on the circumference of the circle. So let's look at the point where theta is equal to 30 degrees or pi divided by 6 radians. At this point, the cosine 30 degrees is equal to square root of 3 divided by 2 and the sine 30 degrees is equal to a half. That means that the x, y coordinates at this point would be equal to root 3 over 2 and a half. If we now look at the point where theta is equal to 45 degrees or pi divided by 4, we see that the cosine of 45 degrees is equal to the square root of 2 divided by 2 and the sine of 45 degrees is equal to the square root of 2 divided by 2. This means that the xy coordinates at that point are equal to root 2 over 2, root 2 over 2. And then at theta equals 60 degrees or pi divided by 3, the cosine of 60 degrees is equal to a half and the sine 60 degrees is equal to root 3 over 2. So the xy coordinates at this point would be 1/2 and root 3 divided by 2.